Hello, class. I just want to go over one problem as a start of our review for the final exam. And one reason why I chose this problem is because I notice on my math lab there are two types of errors for entry. Two input errors that some students are making with my math lab. So I'm going to address those two errors with this problem as well. So here's what we have. Solve the ln of x, this means natural log of x, is equal to the ln of x plus 6 minus the ln of x minus 4. So here's the first mistake that's being made on my math lab. Some of you are inputting IN, a capital IN. This is not a capital I, it's a lowercase l. It's called the ln of x. Okay, and then I'll get to the second problem a little bit later with my math lab. So the first thing you want to notice is you have a difference of two logs. So let's use that property where a difference of two logs can be written as a single log of the quotient of the arguments, this over this. So I'm going to do that first. So here we go. So I've got the ln of x, I don't know why this gets blurry, equals, and now I'm going to write a single natural log of the first argument over the second argument. So there's step one. You got to know these properties of logs. So I got the ln of x is equal to the ln of x plus 6 over x minus 4. Remember, the difference or subtraction of two logs changes to division because the minus sign looks like this, fractional bar. That's a good tip. So whenever you have a minus of two logs, you write it as a single log of the division or quotient. If this were a plus sign, though, I would write the ln of x plus 6 times x minus 4. So with a plus then is a single log of the product of the arguments. But with a minus then, a minus sign, it's just going to be a single log of the quotient. Okay, now let's use another idea. If you have the log of a number equals the log of a number, the numbers must be equal, or the arguments must be equal, however you want to say it. So that's what I'm going to do. I'm going to set the arguments equal. X is equal to x plus 6 over x minus 4. Next, I'm going to clear the fractions to solve for x. Or I could put this over 1 and set the cross products equal. It's the same idea. So I'm just going to multiply both sides by x minus 4. So I've got x times the x minus 4 is equal to simply x plus 6. Because when I multiply this side by x minus 4, this cancels out. I'm just left with x plus 6. And here there is no canceling, so it's just going to be x times the x minus 4. Okay, let's distribute. So I get x squared minus 4x is equal to x plus 6. Next, I want 0 on one side. Don't forget that. That's a beautiful thing to remember when you're solving equations of degree 2 or higher. Almost always you want 0 on one side. So I'm going to subtract x, and then I'm also going to subtract 6. So when I do that, I'm going to do this in one step. You can, figure this out, I think. So I'm going to subtract x to each side, and this is going to become an x squared minus 5x. And then when I subtract 6, I'm going to have 0 on the side. So here we go. I'm going to write x squared minus 5x minus 6 equals 0. So that's what happens when I subtract x and 6 from each side. And now hopefully we can factor, because that way I can use the zero factor rule. So this becomes x, and this is factorable. It's going to be x minus 6, x plus 1 equals 0. Because doesn't negative 6 times 1 give me the negative 6? And isn't negative 6 plus 1 the middle term of negative 5? Hell yeah! Okay, let's set each factor equal to 0, the zero factor rule. So my solutions are going to be x equals 6, x equals negative 1. So with log equations, you always want to make sure your solutions for x give you positive arguments. If they don't, you must reject your x value. But in this case, x equals 6 is going to work because when x is 6, this argument is positive. You go to the original equation, and this argument is positive when x is 6. And isn't 6 minus 4 also positive? Since all the arguments are positive, I can accept x equals 6. I'll box that answer. But x equals -1 must be rejected. Because right here, if x is -1, you cannot take the log of a negative number. So you can stop right there. Reject x equals -1. You can only take the log of a positive number. Okay, so I'm done with the problem, x equals 6. But in my math lab, sometimes they want you to write the solution using a solution set. So what is the answer to this problem using a solution set? So solution set means that you're going to have braces in your answer. And since I only have one answer of 6, this is the way you write your solution set. If they want you to do it this way on my math lab, do that. Do not do this. The absolute, because the braces mean this is going to be your answer. But don't write that. This is wrong. So for solution set, you just write what numbers are in your solution. Don't write x equals 6 with the braces. That's overkill. It's wrong. So either write x equals 6 like this, or on my math lab, they might want you to write it like this. So when the braces appear, don't write x equals 6. Just write 6. Okay. Good luck, everyone. Done.